Well, hello, welcome back to the radio room. I'm going to do a quick video here, hopefully. um, got the, still working on the FT101EE, and I got some parts in. I was mentioning in the last video that I was going to change some capacitors on the power regulator board. Specifically, I was noticing this one right here looks like it's bulging on the bottom there. So I figured we probably ought to change those out. These are 250 volt capacitors. There's also a 160 that I'm going to change out, and see if we can't get these looking a little bit better. Now, as you can tell, those are kind of tall. The new ones, for these blue ones, are not nearly as tall. Should be about the same size around. I did specifically make sure that I measured the diameter of these, make sure that the new ones I got weren't any wider. As you can tell, there's not a lot of room there to have anything wider. Not being as tall isn't as big of a problem, but definitely don't want to make sure they're any wider. So I'll just pull this out and double check it real quick. Yep, exactly the same size as far as width. So we're going to change those out, and hopefully this is going to help this out a little bit. I don't think these have completely failed yet, but I think they're on their way. Probably a little heat in this area, whatnot, might have started causing these to have some problems. So I want to change these out. I also want to change this guy out right here. It's got a pretty good crack in the coating on the other side and just isn't looking too good. Let's take a look real quick at where these capacitors are, and I'll show you one reason why I definitely want to make sure that they get changed. So give me just a moment. Let me get over to that screen, and we will take a look at this. So here's the power regulator unit. In this case, it's PB1547. If you're working on some 101s, these are probably the last regulator board. And one thing I do want to point out is if you have to change any capacitors on this, make sure you get the values off the board, or you go to this screen here. I'll zoom out a little bit, because a lot of other radios have, give me just a moment here, they're this is all in the service manual, by the way, have this one, PB1314. You'll notice the board layout here. Not quite the same, and the numbers are now. The diagram looks very close to being the same, but it's definitely not the same board. Let me go to another screen here. And if you go over to, this is the actual schematic for the radio, 101E. The numbers are going to be different. In this case, the resistor I changed last time was R2. If you look at the parts layout, or the parts list for the radio, it also does not list the board. This is PB1314. I'm trying to show you what I'm getting at here. Let me see if I can find this. Make sure I'm on the right radio here. The service manual has pretty much all of the boards in it. So let's see, regulator board. See, we're going to be changing like V or C7 and C8. They're not numbered the same. So really the only place that you can find this board, if you happen to turn, this is a PB1547. So make sure you pay attention to what board you have. See, PB1547. Make sure you pay attention to which board you have before you just go start looking up values on parts lists. In fact, right here is pretty much the only place I could find specifically the parts list, so to speak, for this radio or this board. This board is not contained anywhere else that I can find except for right here. But we're going to change. Let me get my something. We're going to change these two right here, which is C7 and C8. We're also going to change C1 and C2. Now, one thing I do want to point out here is this has got 160 volt, a negative 160 volts in it, or positive 160 volts right here. This is the screen voltage. Right here is our bias voltage for both our driver and our final tubes. And it's got negative 100 volts on it. These voltages come basically right off of the rectifier board. We do not want these capacitors to short out. If they do, they're probably going to take parts of the rectifier board out and possibly could damage the transformer. If the rectifier board component's held on long enough, it could cause a problem in the transformer. So we definitely want to change these since they're already showing some signs of having some aging, some bulging. We don't want these to fail and start taking other parts of the radio out. So I'm going to change them while I notice them they were bad. That other little one that's cracked is this one right here. So once again, this is right on the output to the you can see negative 20 volts there, 12BY78. That's going to the driver tube as its bias supply. So we want to change these out. We don't want these to short out or anything and start taking other components out in the radio. So we'll go back over to taking a look here, and we're just gonna change them out, swap them out real quick. It shouldn't take too long. Already got the desoldering gun heated up, so I guess we'll start with this one right here. This might take a little bit more than just sucking it out and letting go with it, because when Yaesu put these together, they did bend the legs over just a little bit, so we might have to kind of lift them up and get them straightened out a little bit so we can get them out of there. You'll notice right here, this one's actually bent over. I'm going to see if I got enough solder off of there already. I might have to heat this up to do it. Yeah, it's still soldered there a little bit, so I'm just going to heat the solder and lift the leg up a little bit. And then unsolder it some more. See if I can lift this leg up. Basically, I'm just lifting it up enough that I can get the little hole in the end of the desoldering gun to slide over the leg. And that one's out. Yeah, and it definitely was starting to swell. So that was sitting in there, you know, like that. That's what caught my attention, was Ferroni was leaning, and I could see that that popping out there a little bit. Now, definitely make sure you pay attention to which side your negative stripe is. You don't want to put these in backwards. It's going to be a bad day later on if that happens. In fact, that looks like it might have just started trying to leak. That could just be some dirt on there. But that one's definitely poofing out a little bit. So that one was sitting in there that direction. I am going to kind of clean this board underneath where the capacitors are as I'm doing this. There's no way to get in there once I put the new ones in there, so I'm just using some isopropyl alcohol and going to clean off anything that might have come out of that capacitor if it had done any leaking. The stuff inside the capacitor can start to corrode and maybe even etch some of the traces. These are pretty decent traces, but I want to make sure I get that stuff off of there so we don't have any continuing problems. I'm going to go ahead and get my new capacitor out here. And get it out of underneath the tape. I don't really want to bend the legs. Oh, they're stuck. Okay. I'll just okay, so once I said electrolyte, you got to make sure you put it in the right direction. This one was sitting like this. This one has a gray stripe instead of a black. That's still the negative side, so we're going to put that in as going the same direction. I'm going to keep this off the board just a little bit. We definitely don't have a height problem now. We'll get this one soldered in there. How about I get the sharp razor blade out of my way first. Alright. These are a little warm. So if you're doing this, be careful. Because I'm going to go ahead and trim the legs on it just right above my solder. Like that. And I sometimes keep these. They come in handy sometimes in the future for little jumpers and whatnot like that. I got a little old medicine bottle that I keep them in. Alright, let's move on to our next one. Let's go ahead and do this one. Let's do this one. Once again, a bent over leg. See if this one's released. Oh, still a little. I'm actually going to see if I can suck a little bit more off. I put more solder on the end of this so I can get a little better heat conduction to that leg. There, I think I can lift that leg up now. Now let's make sure real quick, let's make sure we know we got our black stripe that way. And the reason why you want to take note of that before you take it out is because it might fall out. Okay, and that one actually looks like it came free. Yep, it's free. That one out. Now these are 22 microfarad at 250 volt that I'm putting back in here, which matches the same specification as the ones that were in there. These are 105C capacitors. Let's see what these are, if they even say. They don't say. And this one as well was starting to bulge. You can see the end there is starting to kind of push out. So this was a potential failure coming up very soon, possibly. Sometimes when you're working on these older radios, just, you know, you might be in there for one thing, looking at one problem, but try to take a look at other things that are going in there. When you got a radio apart, sometimes that's the best time to see if you can notice some other things and clean them up. Take care of them while you're in there. Once again, I'm going to clean this one as well. Down in there I can see where that one was sitting. Might be some flux from when it was originally soldered in there. Maybe a little bit of stuff from the capacitor. But we want to get that out of there. And once again, going that way. And solder this one in. Let's go ahead and do this one here. It's going to be these right here. And if you're using a desoldering gun, keep your tip tinned on it too. Take note, it's black stripes that direction. Be careful when you're bending these legs up. You know, if you're using kind of a sharp tool like that, try to get just underneath there, but don't really scratch against the the board any more than you have to. For one, to keep the conformal coating, that's the green, on there except for where the pad is. And we don't want to catch that trace and peel it up either. The conformal coating keeps the copper from corroding on the board. We're going to seal that and keep it from corroding on the exposed part because of the solder. So we don't want to have to, have little spots here where it's going to start corroding. Now, in this case right here, this is a ground plane of it. There's a lot of copper there. You could have a little corroded out spot right here. It's not going to stop it from working, but that corrosion could start leaching into the rest of it. And this is a big space. It would take a long time for it to ever compromise the radio. But over here, if we got corrosion, started getting corrosion here, or more specifically here, if this trace were to ever break right there, we would have no filtering on the screen voltage. And once again, bulging on that one as well. And this one, let's see, that's C7. So yeah, these two right here are screen voltage. This one right here is actually on the bias voltage for both the driver and the final tubes. So yeah, they've all gotten a little worn. Probably got a little heat to them, so let's clean that spot up as well. And we'll get this one put in. And before, the stripe was that way. Got a little tape stuck on here. I'm not terribly worried about it as long as it gets through the hole. I mean, our solder is going to be more up in this area right here, so a little tape right there is just going to be in the part that we cut off. Just a tiny bit off the board there. And we'll solder this one in. Alright, as far as electrolytics that we're going to change right now on this one, these are some low voltage ones right here. I kind of looked at them. They don't look to have too much, they're not bulging or anything like that. I've just been changing these high voltage ones. This one right here is 160 volt. Let me find it right here. Now, if you're looking at the schematic, you find this one, and in your, I just want to kind of warn you on this one. So here's our new one. same diameter as the old one. If you look at this one, and this is going to be this one right here. As I've mentioned just a few moments ago, this, let's see, hopefully y'all can see that. See if I can get the light right. This whole area right here is kind of the ground plane. It's chassis ground, it's the 0 volts, it's the ground. As you know, normally in most instances, when you put an electrolytic capacitor in, you normally put this to ground. Not in this case. Remember, we're dealing with negative voltages here. So this goes to the relative lower voltage. In most cases, ground is lower voltage. If you got a 13.8 volt system, normally this would go to ground because the positive side is more positive. Positive 13.8 volts. In this case, ground is a higher voltage, is a more positive voltage. Let me put it that way. It's a more positive voltage than the negative 100 volts that's coming in to this circuit. So if you'll notice, they did put a little positive right there. And if we look at this side, the negative is over there. And it's actually going over here to our negative 100 volts. Well, just because you got the volts listed here and this is ground, don't put this on the ground on a negative voltage system. You'll actually have this in backwards. This is the lower, more negative voltage side. Whether that, if you're in a positive voltage circuit, then that's ground. If you're in a negative voltage circuit, then this is the more negative side. So in this case, it's going to go to the negative 100. So we'll get this one out, and we got to make sure we remember. Of course, this one's sitting in there like this. It's striped that way. But if you look at the other side and say you pulled this out and you like, well, I didn't notice which way that was going. Make sure that you understand what circuit you're working on, and that in this case, the positive side of the electrolytic capacitor needs to go to the more positive side, which is 0 volts, or ground in this case. So let's go ahead and get this one out of here. I'd have to hang more of that one up. They folded that one over pretty tight. That was almost a finger. Now this one's going to cooperate. This one's... Well, I might have to actually heat it to try and do this. Had that one down there pretty tight. I'm going to use a desoldering gun one more time. actually looks like it's already loose. Clean this up a little bit. I did lift the trace on that one just a little bit. Still looks solid there. What I'm probably going to do is, just to be sure, take my little brush here. I'm actually going to, this side of that trace lifted just a little bit when I lifted that leg up. It might have been stuck just a little bit. This trace that's coming this way, what I'm going to do is I'm going to clean off some of the conformal coating on it right there and make it so that when I resolder this, I run my solder out onto this lead just a little bit to make sure that I haven't broken this ring of the solder pad loose from that, and we'll have continuity through there. So I'm just going to clean this off carefully. Just a little spot. Just taking some conformal coating off, and I'll recoat this with solder to reseal it. You can kind of see, maybe. Let me clean the board off right there. You'll be able to see the shiny part of that trace. Now you can probably see it. You can kind of see where I took that green off right here. Actually, you can see it better when I put my reflection of my finger on it. So I'll just make sure I take my solder and cover over that, just in case I broke that pad loose from that trace. And let me go ahead and get in here and clean the top side of the board. Alright. Once again, we're going to put the more positive side towards this hole here. It even has a nice little positive there to let you know. This one has, what I'm going to do, this one has slightly narrower legs to it. They're about actually the same as the original. But what I'm going to do is I'm going to take, find the right one. I got one of my solder tools has got a little slot in it right here. What I'm going to do is I'm just going to barely come down from where they come out, because I don't want to pull these apart in that rubber, because it's going to start pushing against that rubber, and I definitely don't want it to finally break through that rubber. So I'm just going to put just a little bit of a turn on this, just outside of that rubber. Like that. And then I'm just going to come up just a little bit further and bend it back straight. Gets me a little bit wider. I'm just going to keep it off the board just a little bit, but that's going to be okay. The reason why I'm doing that is I don't want the legs coming out of the bottom of the capacitor and just being spread apart like that, trying to go into that hole. I don't want to put any strain where they're coming out of here any more than I have to. So let's see if we can't get this soldered in. I don't know if you noticed that when I was soldering it, my hands were probably in the way. I soldered the leg and then I just drew that solder out to cover that spot I had cleaned off. That'll make sure this is a solid connection right through here. Just in case I broke that one through from the trace lining. I don't think I did. At least half of it was still on there. I think I just folded it up. Alright, we got one more capacitor that I wanted to change. Here's our new resistor, by the way. Right there, that's the one we found was our problem with our bias. We're going to change this one right here, which is those two leads right there. Let's take a look at our new one. This is a 0.047 microfarad 250 volt film capacitor. Right here. A little smaller than the original one, but we got the same lead spacing, so let's go ahead and get that guy out of there. And these are not polarized, so it doesn't really matter which way this one goes back in. So that one, was looking a little rough. See that right there? It might not have been hurting it much, but I just didn't like the looks of this thing. So we're going to put a new one in there. Well, one thing I am going to do, it doesn't matter which way it goes in, but I am going to put the labeling to the outside, so if anybody ever has to come back in here again and take a look at it, they can read it. Oh, let me clean that real quick right there. A lot of flux left over from when they originally soldered all this together. I'm going to keep this off the board just a little bit. I'm going to bend these legs so that it doesn't fall back out just a little bit. that done, and I'm going to clean my flux up on the board. Don't want that to come back and start causing any problems maybe in the future. And you know something? It just looks better. Clean that up around where we work, so there's not a bunch of black, brown, gooey stuff on there. I think it just looks nicer. Probably not hardly going to have anybody in here looking right here, I would think, or at least not very often. Alright, so that's got our 4 new electrolytics on there and a new film capacitor. Got a new, once again, our new resistor that was causing our problems, and we're cleaned up. So I think this board's probably ready to go back into the radio and do its thing. I don't think I'll have to readjust the bias much. It could have had some little change because of this capacitor here, or this one. But I think we're still going to be okay on that one. Mostly just wanted to kind of go over with you working on this board and changing those capacitors out. There's still more work that we're going to do on the FT101EE. There's probably change C13 out, which is the coupling capacitor between the driver and the final tubes. I'm going to take a closer look at that. Like I said, it looks like they've probably been changed, but they put 2 capacitors in series with each other in order to get the right capacitance. And I want to take a little closer look at them, see if they're put in very well, make sure there's no chances of shorting out, especially since there's 2 of them in parallel. Were they insulated good? These things are basically right up against the wall. Underneath of the radio, which is grounded. We don't want several, a couple hundred volts coming in contact with the chassis of the radio. Make sure that looks good. See if I can maybe find out which voltage rating they had on those capacitors. If they're, at least 1,000 volts each, they might be okay. If they're only running like a 500 volt each, it's still got that 1,000 kilo or 1 kilovolt working voltage between the 2, but if one happens to short, the other one's going out immediately. I just don't think it's going to take that voltage very well. So we'll look at that. I don't know if I'm going to be able to, if I do end up changing those, I don't know if I'll be able to get it on camera just because of where they're working. I don't know if I'm going to be able to get a camera set up real close where we are working and still be able to work. Another thing is, after we get the other capacitors, if I end up changing that C13 out, what's in there might be good. It might work fine. I just want to take a closer look at it. Check C131, see what it looks like. If it needs to be changed, I'll change it. And then I'm thinking what's probably going to have to come next is, remember, 10 meters is still way down. Find out what's going on with that. And I'm wondering if maybe just starting an alignment on the radio might bring that up. I did go through and check the crystals in this radio, and the crystals are all good. It does have an 11 meter crystal in the auxiliary position. So I definitely think I want to check the alignment. 10 meters might not be there. I probably need to check the radio and auxiliary, see if it'll load there. I'm wondering if the 10 meter adjustments in the alignment may have been realigned to try to optimize that 11 meter crystal. So that might be why 10 meters is out, is it's actually detuned. So we'll take a look at that if I can get enough output on it, but it might take a little bit of an alignment to get things a little closer to alignment before I can really go through there and set things the way they need to be. One thing I definitely want to do is try to make sure that this radio, the tubes are neutralized properly. And when you have like zero output on 30 megahertz, or 29.99, whatever you want to call it, it's hard to tune the radio for maximum output at that frequency and then do a neutralization when you can get literally no power out of it right now. So it might come to like a front end alignment on the transmitter and do the receive at the same time. Then neutral, see if I can get the power output so at least I can make sure that everything's tuned and resonant right, and see how the neutralization goes. If I can't get it to neutralize, I suspect that might be because of the one capacitor that needs to be changed for American tubes. But I'm going to try it with the one that's in there. Like I said, there's been people that have taken American tubes, put them in an FT101, did not change that neutralization capacitor, and still got it to neutralize. So before I go changing it from 100 picofarad to a 10 picofarad, and let's see if it'll neutralize the way it is. But that's one thing we definitely need to make sure we get done before the radio is done. Definitely looks a little different here. It doesn't take up as much space. There's going to be a little bit more space in the radio right there. These newer capacitors are definitely smaller. Same ratings, same capacitance, same voltage rating. These are 105C capacitors, so if there's some heat, they're gonna stand up to it a little bit better. Well, I just wanted to go through this real quick, just literally without cutting or anything. Put the capacitors onto this board. I'll probably get them into the radio sometime maybe later today or something. Get this board back in and kind of see where I go from there. But I think we're definitely making progress. This one little resistor was holding us up for a little bit, and on visual inspection, I had already pulled this board and visually inspected everything here. The hardest part is like this resistor here, because of the way it's in the circuit, you can't just put a DMM on the two contacts here and get the right reading, because of the way there's other paths for it to go that your DMM is reading, so you can't get it until you literally pull it out of there. Visual inspection looked good. Now once I had this one out, I could actually test all the other ones, because as you remember looking at the diagram, it was basically kind of a circle of resistors leading to ground in multiple paths. So that was throwing things off, trying to get the reading for that. Once I popped it out, checked it, I was like, well, yeah, that one's definitely not going to work. And if it went up, it's doing exactly what it would do if the resistance went up in value. Anyhow, hope you enjoyed watching me do a little soldering and desoldering. We're going to get this in here, and we're going to continue working on the 101 double E. And so come back for more, and hopefully when we get all this done, we'll have a very nice talking FT101E with good output. Thanks for stopping by, and bye for now.